Hey everybody, I am Chris Nova. I flew all the way from Denver, Colorado to come and talk to all of you about Kubernetes. So I'm going to start off, I'm going to tell you a little bit about myself and kind of how I got here. And then we're going to do a high-level kind of overview of Kubernetes. I'm going to talk about some Microsoft stuff and some philosophy behind Kubernetes, and then give you a good idea of how to get started with this moving forward. So I started working with Kubernetes about 1.5 years ago. It took me about 6 months, and then I got my first contributions in, and now I'm a full-time maintainer of the Kubernetes project, as well as the Kubernetes incubator organization as well. I work at Microsoft. I joined Microsoft earlier this year, so I'm relatively new. So far it's been great, and they flew me all the way out here to Tel Aviv to talk to everyone. So a big part of what I do and what I've always done is work in open source and Linux. So naturally I was a bit confused when Microsoft reached out to me and said, hey, we're interested in you. But so far it's been freaking great. I write a ton of Go. I actually just got my name in the Go authors file as a contributor to the Go programming language itself earlier this year. Thank you. So that was super exciting. And I've been in there, I think, 2 releases now. My name's in there, so that's cool. I work in our cloud at Microsoft. I do a lot of work around Azure. When I started off working here, it was coding as a proper software engineer in Azure, and now I have since switched over to the CDA team. So I can talk about all the stuff that they were coding in Microsoft Azure. Also, I wrote this really awesome book that you guys should totally check out. It's called Cloud Native Infrastructure, and it's this really cool idea of how we as DevOps engineers are going to manage infrastructure in a cloud-native way moving forward. And you'll kind of learn some of the lessons in the book throughout this talk today as we talk more about Kubernetes. Okay, so my Kubernetes story, I figured it was important to tell you guys so you know a little bit about where I'm coming from and how I ended up here on the stage in front of you today. So a long, long time ago, in a data center far, far away in Kansas City, Missouri, I started polishing fiber and provisioning network switches. This was about 10 years ago. Since then, I have taught myself how to write Bash, and how to write better Bash, and then how to write even better Bash, and then it eventually moved on to the Python programming language. I wrote Python professionally for a couple of years, and this entire time, I was following this trail of managing infrastructure and making it easier and more, I guess, automatable along the way. And as I was doing that, I found myself basically orchestrating virtual machines. So going to data centers and writing Python programs and Bash programs that would help me manage these virtual machines as a single human. I came into one job, there was 4 people who would drive to the data center every day, and I came in and wrote some software, and I was there, I think, twice a year by the time I left. And I did that all by myself. So anyway, I got really good at managing these whole virtual machines. So somebody noticed that, and they were like, hey, you should come and you should write Go. And I said, I love Go, I really want to learn it, I've been researching it for a while. This is back in about 2014, and they roped me into the Kubernetes ecosystem last year. So the 3 things that I'm probably most involved in that sort of brought me here today are COPS, where is that? Kubicorn, and the SIG cluster lifecycle. So COPS is this infrastructure provisioning tool. I'm a maintainer of it. I started last year. It allows you to declare an intended state of infrastructure, and then it can go and reconcile that state. And this is a very Kubernetes way of thinking, and we're going to get more into this later. But the tool, for all intensive purposes, can be thought of as infrastructure management, helping you set up a cluster. Kubicorn is my own personal rendition of this. I woke up one morning and said, I want to do things a little bit differently, and I have some crazy ideas, and I'm going to write a book about it and call it Cloud Native Infrastructure, and then I'm going to write this Kubernetes deployment tool called Kubicorn that is a concrete implementation of how to do this. All of this is managed through the Kubernetes open source project through these things called SIGs, which stand for special interest groups. A SIG is just a group of people on a call from all over the world. I was on the beach on one of these SIG calls last night, which was morning for the people on the call. And that's where we manage a lot of these types of tools and sort of discuss engineering concerns, or bike shed, as we probably more appropriately should say. Okay, so what is Kubernetes? This is like the banality of my life. I get asked this question like once a day, and I don't have a good answer for it. And I always like struggle with, do we need to go sit down and like order some beers and talk for 6 hours? Or do I just give you this sort of superficial high-level pitch and hope you can kind of put the pieces together? So today I'm going to be talking about what I kind of view as the happy medium, and hopefully you guys can take this idea and run with it. So we're going to break down Kubernetes into 3 things. And I want to keep them simple so that we all kind of can get an idea of what it is, and then we're going to go through and we're going to explore it in a little more detail, and you'll see how at the end of the day, all of these 3 things are really kind of what's going on. So number 1, it's an abstraction layer for the cloud. When I say abstraction, I mean we take an idea that's concrete. Let's take a load balancer in Azure, for instance, and we pull that up a level and we abstract it and we call it load balancer. And we don't really care about the implementation. So we do this with ideas in the cloud. It's a few containers. More realistically, it's a lot of containers, but it's containers, and that's really what's important here. So the software that's running to create Kubernetes is all encapsulated into a container. And third, there's this agent. It's called kubelet, and it runs and is watched with systemd. And really, these are the 3 things that you're going to see if you look at what Kubernetes actually is behind the scenes. And I wanted to keep it simple, and we're going to dive into it a little bit more. So this is the Kubernetes control plane. This is the brains of the operation. This would run on a virtual machine, and that virtual machine can be thought of as like the master for the cluster. So the control plane has these basic components. It's got some client, which can be anything. Command line, it could be another program, it could be somebody curl minus capital X, like somebody sending an HTTP request, or something sending an HTTP request. It's got this API server, which is this like fuzzy blob that you can just sort of think of it as like somewhere on the internet. And then we have these 2 containers, the controller manager and the scheduler. And the controller manager reads from the API server, and the scheduler also reads from the API server. And the API server stores all of its information in etcd. And this is a very basic model. I would say most software systems I look at look something like this. There's an API surface, there's some database to go store some data in, and then there's some application-y bits that like do something. So anyway, this is the high-level view of the control plane. But if you look, bam, there's our abstraction, the API server, and these are all containers. etcd runs in a container, the scheduler runs in a container, and the controller manager runs in a container. If you go and SSH into one of these nodes and you do a docker ps, you're going to see 3 containers. Theoretically, you could docker run, and if you structured your command correctly, you could get a control plane up and running just by doing docker run commands. So the workhorses of Kubernetes are these things called worker nodes, or some people call them hosts. And these are what communicate with the API server, that same API server we just looked at. And these are what your application runs on. So in this diagram, we have 3 hosts, which that could be 3 virtual machines. And really, that could be some number, 1 or greater. And contained on each of these virtual machines, we have a couple of things. At the top, we have 2 containers, each containing your app. It could be anything in the world. And then we also have systemd, which will watch the kubelet. Now, the kubelet does not run in a container, although some people do run it in a container. But the kubelet is, I always think of it as like a proper Linux service. You can systemctl, and you can interact with the kubelet like that. There's a file that configures it, and it runs and is watched with systemd. So the kubelet talks to the API server, and the API server talks back to the kubelet, and then the kubelet will take care of running your app if necessary. And again, your app are just those containers there. Again, looking at our 3 things, there's our abstraction. Hey, there's that agent we talked about. And here are these containers. In this case, they are not Kubernetes containers. They're your containers. But they run in the same way that the other containers in Kubernetes also run. So again, what is Kubernetes? It's an abstraction layer for the cloud. That's the API. It is a few containers. They could be yours, or they could be the official Kubernetes components containers. And it's this agent that runs with systemd. And with all of those components starting to sing together in a happy marriage, you create a Kubernetes cluster. And you can see that scaling your cluster is now an exercise of scaling a set of nodes that have a kubelet, the agent, running on them, and reporting back to the central API. So, the Kubernetes API. In my mind, the Kubernetes API is the most valuable part of this entire system. And this is almost a philosophical exercise instead of a technical exercise. And to kind of understand the importance of this API, I'm going to compare it to the Linux kernel API. So the Linux kernel API is an API that existed long before we have what we think of APIs today as RESTful APIs. This is a proper programming interface. It's written in the C programming language, and you can include various parts of this program and interact with it. And this API is versionable, and it's reliable, and it's documented. And it's a reflection of many, many people coming together and arguing for hours over email. Kubernetes does the exact same thing, but for the cloud. So it's an abstraction, and on top of containers and cloud resources, you find the Kubernetes API. And just like the Linux API, it's versionable. And just like the Linux API, it is standardized, meaning that you or I, if we chose to interact with containers or cloud resources, could do it in such a way. So that's really what Kubernetes is offering, is almost a standard. So if we look at the HTTP protocol, my microphone's falling off, it's a reflection of a bunch of people coming together and saying, I think we should all make our computers speak the same way. And then we drafted up this RFC, and it was thus created, and then poof, HTTP happened, and now all of these computers can talk to each other. And they all talk to each other in the same way. Kubernetes is offering this idea that if you're going to be building out things on the cloud, you should do it in a standardized way, so that you can plug in your components to other systems. And we kind of don't care about the implementation underneath. Just like the Linux kernel API, I don't care what computer you have running underneath. That's like hardware implementation details. I just want to interact with a standardized library. Kubernetes says, I don't care what cloud provider you're running underneath. I want you to interact with these cloud resources in a standardized way. So the Linux Foundation, we've been doing all this talk about Linux, created, well, I guess I shouldn't say they created, but there is the Cloud Native Computing Foundation that is now a subsidiary of the Linux Foundation. And if you think about that, that's pretty powerful because we learned a lot of these philosophical lessons with things like glibc and Linux. And now the Cloud Computing Foundation is getting a really unique opportunity to sort of give it a version 2.0. Furthermore, let's look at people who have joined the Cloud Native Computing Foundation. These are all very important leaders in the technical space. The fact that they have all joined together to say, you know what, we're going to start looking at this Kubernetes abstraction thing and taking it seriously is fairly powerful. And I think it's a really big, important thing that we need to realize that these people who are shaping the cloud, and therefore shaping the earth, are coming together and saying, let's start speaking this standardized way. Okay, so we're going to talk a little bit about the Kubernetes API. And we're going to look at these things called resources. And a resource, it's like, you'll sometimes hear it called an object. You'll sometimes hear it called a primitive. But really, it's just an idea. Also, each of these resources, they kind of follow this unit philosophy of doing one thing and doing it well. So we try to keep a single concrete use case encapsulated in a single Kubernetes resource. Each of these resources can be encoded and decoded into YAML or JSON or XML or any encoding language for that matter. We typically use YAML with Kubernetes space, and I guess it's where you can use encoding language. But it's a data structure. That's it. It's just a data structure. Each of these resources is declared in nature. And then we start to look at how Kubernetes works in a second to sort of understand the importance of this declared way of doing things. But the idea is that if you want something to happen, go and you declare it. And whatever one of these resources is should take action with whatever it is that you declare. So the first resource I want to talk about today is this thing called a Kubernetes pod. And a single container, or more than one containers. If we look at the top, we say a kind pod. And we're going to go through this kind of line by line just to make sense of it. And what that is doing is it's saying, of all the resources, this is the kind that we call a pod. And a pod is a Kubernetes term, and it just means a container or a set of containers. If we scroll down, we look, we have metadata, and we have name is equal to my app. We have given it a unique string that we can then use for all kinds of things later, to select on, to look up on, or to filter on. Every Kubernetes resource has a sub-object called spec. And a spec is nothing more than the definition of what you, the user, cares about. So in this case, we have a single container within our pod that we will also call my app. And if you look, it's pulling from my Docker registry, Kris Nova, and then my app, and then we're using the tag 1.3. And then there's our container port 80, HTTP, my jam. But anyway, looking at this, you can sort of see, like, this is really all you care about as a developer. Like, I want to say, here's my Docker image, here's my container image, and here's a port. And then, like, go do the rest. So this is one of those abstractions. And this is one of the fundamental pieces of Kubernetes. So next we have a service. A service, I always kind of think of it as like a network rule, kind of. Maybe more network traversal. But anyway, we look at the top and we say kind is equal to service, and we have metadata again. Name is equal to my service. We see spec again, and we see selector. Now selector is how you would pair a service to this last resource we just created. And if you notice, it says app is equal to my app. So the name of the pod that we just looked at will do a string compare and a match based on this selector. And that's how Kubernetes knows to pair this network traversal rule to whatever arbitrary app you want. Furthermore, we open up a port 80, and we tell it where we want that port to go internally. So we're given this flexibility of defining these like network rules and building out these pretty mature applications, but like I've done it in less than a kilobyte of text for 2 resources. Furthermore, with a service, you'll see that there are different types, not shown here on this slide. But a type can be anything from a load balancer to a node port, and depending on your network setup and your network topology, either one of those will be relevant. In the case of running in a cloud, a load balancer is going to do exactly what you think it does. It's going to load balance on that port, and it will be routed directly to that container that you just defined. So with both of these resources, I could effectively get a load balancer that will route HTTP traffic to an arbitrary application, and all I had to do was call a Docker image and create these 2 resources in Kubernetes. Furthermore, Kubernetes allows these sort of higher level objects to come together and say, I'm going to start to control lower level primitives. So I always look at a deployment as like a set of pods that's versionable. So in the first example, we looked at a pod, and you could say, here's my Docker image, and it would run, and that's perfect. And if that's what you want, by all means, stop there. But we also have deployments, which are slightly more mature, and if we go and we go through the YAML here, we'll see kind is equal to deployment, and then we have our spec again. But look, we have replicas equal to 3. Remember we had a load balancer in front of those other containers that were running, and now we set replicas equal to 3. So what do you think is going to happen? That load balancer, which is a cloud level resource, is going to load balance across these 3 containers. Furthermore, depending on your node topology, those containers might actually run on different virtual machines that are actually spanning different fault tolerance zones. So you can actually get some pretty advanced high availability with relatively low overhead. Furthermore, this thing is versionable. So you can go in and you can say, you know, I want a deployment of version N, and then you can have a concept of that version, and you can update it moving forward. And Kubernetes sort of supports all of this out of the box. So earlier I had mentioned we're going to do this declarative model. So I'm going to kind of walk you through what it would be like to interact with Kubernetes and one of these resources. So we're going to start in the bottom left on the command line. So here's just an empty cursor on a command line. I've downloaded a few static binaries. They're setting up my path, and we're ready to start rocking and rolling with our Kubernetes cluster. So the first tool that you'll ever want to worry about is this first one called, I call it kubectl. A lot of people say kubectl or kubectl. And that is sort of the user land experience of Kubernetes. So from here, we could follow Unix parlance and say anything along the lines of kubectl get pods, which would return a list of all your pods, or kubectl create pod, and then you would give it some more information and it would go and create a pod. And if you have these YAML files locally on your file system, you can edit them in your text editor of choice, Emacs, and you can send them up to the API server. So the API server is going to take one of these YAML representations that we just looked at, and it's going to say, oh, this is new. I need to save this. Let's put this in etcd. So then it goes into etcd. And then we have these control loops that run over and over again that we call controllers that are going to query the API and say, hey, what information do you have? And the API is going to return the most recently saved transaction, and the controller is going to go, aha, I have audited what's actually in existence right now, and I have detected that this is not running. So I better do something. I better take action. I better create this. And that's how one of these resources goes and gets created. So we have all of these really, really nice, clean ways of separating our code into different paths that say, oh, I would like to create a load balancer, and we're going to take action because somebody just told me they wanted a load balancer. And then there's a switch that happens at runtime that says, oh, we're running on Azure. This is how I create a load balancer on Azure. Or like, oh, we're running on Google. This is how I create a load balancer on Google. And if you know anything about the Go programming language, Go interfaces were built for this ideology. So I'm going to talk a little bit about what we've been up to at Microsoft and some of the tools around Kubernetes that I've just been kind of talking to you about. So the first one is Azure Container Services, and we were the second of the 3 large cloud providers to offer an enterprise-level Kubernetes service. It's called ACS. When I first joined Microsoft, I worked on this team. I wrote code for this team. It's actually, I think, running in production now, and I hope it works. I'm kidding. But let's look at what the Azure Container Service does, high level and philosophically. So to start at the top, we have our control plane, and we have these things called agent pools. Now earlier when we looked at Kubernetes, I talked about the master, and that's called the control plane. And I also talked about these arbitrary sets of nodes that you can build, and in Azure land, we call these things agent pools. And it's a set of virtual machines. And in this case, we have 2 agent pools. So let's just say the first one has 3 virtual machines that are pretty big, and the last one has 100 virtual machines that are huge. Bringing that down a notch, we can see that the underlying infrastructure is actually all Azure resources. We have virtual networks, we have load balancers, we have proper virtual machines, and if I was to go into the Azure console and click around, I would actually be able to see these things created. And then all of that happens in Azure through this really cool system that we call ARM. So you can go today and with ACS Engine or through the portal, and you can actually create a Kubernetes cluster right now, and you would get a control plane and some agent pools. And you would be able to add agent pools and subtract them as you wanted to grow or scale your cluster. Now that's important because all of these containers that we're scheduling in Kubernetes get spread evenly across each of these agent pools. The next one, and this was released after I joined Microsoft in April, and I think this thing, hands down, I did not see this coming, and when I first read about it, my mind was like, bam. This was revolutionary in my mind. And this is Azure Container Instances. And so what we did is we allow you to just run a container. So remember earlier when I talked about pods, and really all you care about is like a port and a container. This is, in my mind, this is pods as a service. If I just want to run a container, Ubuntu, Nginx, Docker, whatever, I can go through Azure and just get it up and running. And I can tell it what port I want it to listen on, and I can use that for anything I want. The next one is Managed Kubernetes, which we call AKS. And this thing, I worked on it. We announced it yesterday. So this is a huge deal. We're the second cloud provider of the 3 large cloud providers to offer enterprise Kubernetes. And I'm going to tell you a little bit about what this is and how it's different than ACS, the first one we looked at. So the user experience here is AZ, which is our Azure command line tool, AKS create, and then that's going to send a message up, and we're going to get an API server. This same API server that we talked about the entire presentation, that is the Kubernetes API server, And then that API server is going to come with a subset of hosts. And these hosts are the things your container runs on, using that same Kubernetes topology we've looked at earlier. What's really great about this, though, is the API server is now hosted and managed by us. So in the first example, you would have to manage the control plane yourself. And in this example, we'll handle that for you. We'll take care of your upgrades. We're going to take care of making sure that everything is happy. And we're going to take care of any bugs that come up in the Kubernetes code base as we keep your control plane happy. Which means you, as a consumer, only have to care about a virtual machine running an agent. That's it. Furthermore, because this is all happening over TLS, those hosts can be anything. I've talked with people who are like entertaining the idea of running this on Raspberry Pis, or plugging in their server that's sitting in their closet, or creating other agent pools in Azure or any other cloud. But the point is this is a very flexible model, and with Azure Managed Kubernetes, you're able to start exploring ideas and starting to really look at owning your cloud with Kubernetes. Also, if we look at this possibility of AKS and the ACI connector, we can now see how we can start to do even cooler things with Kubernetes because everything is now speaking these standardized interfaces. So in this example, we have the hosted control plane, the API server, that is the Kubernetes API server, and we have this interface. Now this is a Go interface, and it's what structures the kubelet, which is the agent running on each of these hosts. And we actually were able to spoof that, or mock it, or trick the API server into thinking that we were actually the kubelet running on a regular Kubernetes virtual machine. And now when a work is sent from the API server out to the kubelet, we actually can send that out to ACI and get per second billing for all of your containers. So now you're getting all the flexibility of Kubernetes with burst capabilities of ACI. And this is, we have a software repository in place today that does this, and I think we're working on beefing that up a little bit and getting it really, really polished super, super well. So anyway, I hope you're as excited about all this stuff as I am, and I really hope that you guys will go and take a peek at some of these products. So anyway, getting started on Kubernetes, I'm going to go real quick. I have about 3 minutes, and I'm going to try to just keep this high level because I want you to get excited, and I want you to learn on your own, and I don't want you to tell you how to do everything because nobody really wants to sit to get explained to. So the 3 steps to getting started on Kubernetes in my mind are, number 1, you got to get a cluster. I don't care where it comes from, just get a cluster. Number 2, run an app. And number 3, check it out. We all know what a WordPress app looks like. It's like a MySQL database and an API server. It's not hard, but it's a really great example and a really great opportunity for you to go and see how all this stuff is working together and start to explore the command line tools. So if we look at getting a cluster, there's a ton of solutions out there. There's Terraform, there's the Microsoft products I just talked about. Google has one, Kops is a great tool I worked on, as I mentioned earlier, and Cubicorn is one as well. And there's more than this. This is just like the cusp of the surface of ways to get clusters up and running. So going through this journey of figuring out how to get a Kubernetes cluster up and running is an exciting part of learning Kubernetes. Number 2, run an app. So these are all images from the Helm stable charts repository. There's a ton of great information on Helm. I love the Helm team dearly, and they're some of my best friends. And they have this really awesome tool called Helm that basically is a package manager for Kubernetes. So at the command line, I could Helm install Minecraft. Like literally, that's what I would type, and I would get a Minecraft server running in Kubernetes. We could run Hadoop, we could do MySQL, RabbitMQ, MongoDB. These are all packaged and ready to go. And the beauty of Kubernetes is because this is encapsulated in YAML, if you want to change something, it's a text change. So go change it, play with it, see what's going on. So you can find all of these in the charts repository for Helm. So here's actually what it's going to look like for you on the command line after you get a Kubernetes cluster up and running and after you get one of these charts deployed. So you can see here where we're doing kubectl get pods and kubectl get deployment and kubectl get service. I really want to encourage everybody here to go download kubectl and do --help and start to play and navigate and learn. I could sit up here for 2 hours and show you every possible combination and permutation of commands here, but the idea is that the tool is designed to be user-friendly. It's supposed to be driven like a car. If you don't know how to do something, --help, and it will give you an example and explain exactly what you want to do. It's actually pretty cool. Also, if you look at kubectl get service, that's actually the same command as the fourth one, kubectl get svc, because all of our resource types can be shortened to 2 or 3 letters. Oh, and I'm getting flashed at. So anyway, here's what it looks like if you wanted to build an application and run it in Kubernetes in the same way you're running one of these charts. You would take an app, you would do a Docker build, a Docker push, you would push it up to a registry, and then you could either do a Helm install or a kubectl apply, and that would go to the Kubernetes API server. In the exact same way we installed Minecraft or Nginx or MongoDB or any of the other charts we just looked at. So here's my overview, and then I promise I'll get off the stage. Kubernetes is an abstraction, and in fact it's a very valuable abstraction, and it's an abstraction that's probably going to change the world. Furthermore, Kubernetes is simple. I broke it down into 3 things: containers, an agent, and an abstraction, and that's all it is. Don't be afraid of it. Right there, Kubernetes, an abstraction layer for the cloud, a few containers, and an agent that runs with systemd. And it works for us at Microsoft. I've worked on these teams. I've built tools around these interfaces, and it works beautifully. It's like USB. I just plug stuff together, and it works out of the box. And we're doing this at Microsoft, and we're structuring our applications in this way. Kubernetes is also for hackers. If you like hanging out on the command line and using Linux and exploring like what I consider to be the new Linux kernel of 2017, Kubernetes was made for you. Go, explore, break stuff, get dirty. Like, that's the whole point here. So I want to invite everybody to reach out to me, reach out to Microsoft, any way we can to help, and let's see if we can't really make this Kubernetes thing happen. So thank you.